Thank you for joining me for today's presentation. While you sit as an individual watching today, I want you to consider that even though you may be watching alone, you are also participating with hundreds, if not thousands of others around the world. Think about that. Thousands of women and men coming together to learn and to support diversity, inclusion, and STEM. Pretty impressive, isn't it? And you are part of that. So now let me share the information that connected us for this presentation. I am Suchandra, a PMP, Lean Six Sigma Black Belt, ISO 9001-2015 lead auditor, certified electrical engineer with a master's in electronics and telecommunication. I have over 20 years of experience in various national and international EPC projects. I've worked with Bechtel India Private Limited, L&T Larsen & Toubro, ABB, and currently I'm working with Hatch Associates India Private Limited as an engineering consultant. Today we are going to discuss about Lean Six Sigma in project engineering. Discussion overview and objectives. This session provides an overview of Lean Six Sigma, its application in project engineering, and the role of leadership in implementing Lean Six Sigma. At the end of the session, you will be conversant with what is Lean and Six Sigma, the characteristics of Lean and Six Sigma, and how they fit together, how Lean Six Sigma improves business performance, Six Sigma goals and approach, the RDMAICR process improvement methodology. RDMAICR is recognize, define, measure, analyze, improve, control, and realize. These are the phases. Purpose of each phase in RDMAICR, application of Lean Six Sigma in project engineering, role of leadership in implementing Six Sigma in an organization. These are the contents that we will be discussing today. And now let's start with the introduction to Lean Six Sigma. We have a process, but do we know our customers' expectations? Are we meeting or exceeding our customers' expectation? Have we identified the critical to quality variables in our process and the factors influencing these variables? We need to predict and achieve success by reducing variation in our process. Predictable success through process management and Lean Six Sigma. Einstein was once questioned how to spend your time if you are given a problem upon which your life depends and you have only 1 hour to solve. The answer was, I would spend 30 minutes analyzing the problem, 20 minutes planning the solution, and 10 minutes executing the solution. So you can well understand that analyzing the problem is very important in solving a problem. Lean Six Sigma refers to overall strategy to improve growth and productivity as well as quality measure. As a strategy, Lean Six Sigma is a way to achieve performance breakthroughs. It applies to every function in an organization. Lean Six Sigma is an overall management system and a way of life. Now let's discuss about the history of Lean Six Sigma. In early 1950s to 1975, Toyota production system emphasized removal of waste, improving flow, and improving customer value. In mid-1980s, an engineer at Motorola, Bill Smith, showed direct correlation between field defects and defects found during product development. And this led to the birth of Six Sigma. Initially, goal of Six Sigma meant no more than 3.4 defects per million. Early 1990s, Honeywell, Texas Instruments, Eastman Kodak, and other organizations adopted Six Sigma. Six Sigma MAIC process, that is measure, analyze, improve, and control process improvement methodology, were created. In 1995, GE adopted Six Sigma and added defined phase to MAIC, resulting in today's DMAIC process improvement methodology. GE reported Six Sigma resulted in a net cumulative cost saving of $4.5 billion around in 2001. Six Sigma starts gaining significant interest from our companies worldwide. In the early 2000s, Lean was added to Six Sigma methodology, resulting in Lean Six Sigma. Now we will be discussing about Lean concepts. Lean is a systematic methodology with the goal of creating value that is used to reduce process cost by removing waste, accelerate process velocity, improve product and process quality by reducing opportunity for defects. So in Lean, we use a concept of value stream. A value stream is a set of all the specific actions, value and non-value added activities required to bring a product or service from concept to the finished good being delivered in the hands of the customer. So from concept, how a product is developed, we create a value stream of all the activities. And from that, we finally find out the work that is required, that is the value-added work and the non-value-added work. And this, then we team out the non-value-added work and just keep the try to keep the value-added work so that the time for the activity and the cost, everything reduces. So we improve in time and cost and also the resources required, manpower, everything in this type of management. We are going to discuss about the Six Sigma concepts now. Six Sigma is a process methodology that allows us to predict our process-based performance on projects. This predictive capability is our key to managing risk. We manage risk by using Six Sigma to reduce variation. Our ability to predict our performance is the key to our managing risk. Six Sigma tools allows us to analyze collected data and gain insights as to how process performs. Reducing variation can minimize the number of defects. Six Sigma is uniquely designed to reduce the variation in processes and process variance. Variation is typically measured using standard deviation or sigma as our unit of measure. A process is a series of activities that converts the inputs into outputs. All work is performed within process, and we know that the quality of a process output is directly related to the quality of the process that produces it. A stable and highly capable process will generally result in a predictable, high-quality product, while an unstable or incapable process will result in defective products. We refer to the process output as Y, and we refer to the inputs as X's. We can mathematically represent the relationship as Y is a function of X. What causes a process to produce defective product? The answer is variation. Variation is any deviation from the norm. Variation is present in the output of every process. The degree of variation of the output is a measure of the process capability or maturity. Customer specifies the lower specification limit and the upper specification limit for any of our activities. And the variation outside the customer specification results in defects. Therefore, it is important to reduce variation. So if you see in our day-to-day life, it's actually, this is basically a way of life. And we need to standardize our activities and reduce the variation. While cooking, if you can see, if we standardize the ingredients and the inputs for the cooking process, then it will result in a better output and a standard output with less of variations. So taste, smell, look, all will be more or less similar every time. So this is a way of life. It's basically Six Sigma. We can use it, Lean Six Sigma, in our day-to-day activities. So what is variation? Variation is a key focus of Six Sigma. Variation means that processes does not produce consistent, predictable results over time. Variation exists in all processes. Variation may result in defects, and defects may lead to unhappy customers. So when you have less variation, the quality, the cost of poor quality is less, the quality is good, and your customer is satisfied, and automatically you get repeated orders from the customer. This is what we need in our business day, in our activities. So Six Sigma goals: reduce process variation within specification limits, the upper specification limit and the lower specification limit. So we need to reduce the process variation. And the goal is to minimize variation and center the process. We'll try to minimize the variation and center the process. Shift the process to the center, move average process performance to target. A Six Sigma process allows for long-term variation within customer specifications. The Six Sigma approach. All work occurs in a system of interconnected processes. Variations exist in all processes. Understanding cause of variation are the keys to success. Reduce variation in output Y by controlling the inputs X's. Reduced variation results in improved customer satisfaction. Some people ask, which is better, Lean or Six Sigma? The answer is, it depends on the application. Both have their own strengths, and an organization should draw on the strengths of each. While the purpose of Lean is removal of waste, the purpose of Six Sigma is to reduce variation in order to eliminate defects. Lean results in reduced waste and increased efficiency, while Six Sigma results in less variation and consistent output that meets customer specification. The end result in both the cases is customer delight, which is why Lean and Six Sigma form such a powerful combination together. How Lean Six Sigma improves business performance. We are more focused on business performance. Lean Six Sigma philosophy is reducing variation. That is by getting a product or a process to perform within customer specification, or by eliminating defects resulting in improved customer satisfaction, reduced cost of poor quality resulting in improved operating cost, and increased profitability, gaining predictive outputs. Then it comes to eliminating waste, that is by removing unnecessary process steps or product features, which will result in reduced operating cost, improved cycle time, and improved product and process quality. Now let's discuss about the RDMAICR, process improvement methodologies. So what is RDMAICR? It is recognize, define, measure, analyze, improve, control, and realize. So the RDMAICR is the approach of Lean Six Sigma. Now we all know about the PDCA cycle: plan, do, check, act. PDCA is an iterative 4-step management method used in the business for the control and continuous improvement of processes and products. So you can see that concept is basically a PDCA cycle. In the recognize phase, there is organization driven. The organization recognizes the requirement of the improvement. And then in the define phase, the practical problem statement is defined. And then comes the measure phase, wherein the quantitative problem statement is defined. Then the data analysis is done. Then in the improve phase, the quantifiable conclusion is done, and practical conclusion is done in the control phase. Then the target is achieved, it is in the realize phase. So we see in the recognize phase, the organization recognizes the need for Six Sigma, identifies areas of opportunity, prepares to implement Six Sigma. So the processes which are used are to understand the potential benefits of Six Sigma, rank business goals, objectives, and issues. So we have several tools which are used in each of the phases. In the recognize phase, we use the tools that are economic value add, balanced scorecard, value stream mapping, strategic planning, and FMEA. So in recognize phase, the question that is answered is what is required to be done. Then comes the define phase. In the define phase, projects are identified and defined. Key team members, including black belts, are selected. The processes are fundamental of Six Sigma understood, set and define business goals and objectives. Assign projects to selected black belts, estimate financial impact. Then comes the tools used are project scoping, financial estimates, project management, descriptive statistics, and macro mapping. In the define phase, we define what is important. So a project charter is created, develop the business case, translate the voice of customers, and map the process high level. So we have understood the recognize phase and the define phase. Now comes the measure phase. So we have defined the problem statement and we have found out that what are the issues we need to solve. The first phase of the MAIC process. MAIC is measure, analyze, improve, and control process. Process is mapped, evaluation of measurement systems, and process capability established. The processes that are used are define the project definition, document input and output variables, analyze measurement system, determine process capability, and the tools which are used in this process are detailed process mapping, cause and effect matrix, fishbone diagram, lean tools, data collection systems. In the measure phase, we answer the question, how are we doing? So we identify the potential causes, identify vital few from many, verify the measurement system, develop a data collection plan, gather data, identify patterns in data, determine baseline process capability. Then comes the analyze phase. In the analyze phase, data is collected on the process input and output variables. Critical variables identified through graphical and statistical techniques. So the process is identify possible drivers of variation, determine significance level of each driver, brainstorm any potential design experiments. The tools that we use are ANOVA, hypothesis testing, FMEA, correlation and regression, and graphical techniques. So in the analyze phase, we answer the question, what is wrong? Process analysis is done and then verify and quantify causes X, and the data analysis and process analysis is the activities that are done in this phase, and verify and quantify the causes X. We find out the X, the input variable. Now in the improve phase, the transfer function y is equal to fx is obtained through experimentation. Screen critical inputs through DOE, design of experiments. Search for interactions through DOE. Define y is equal to fx. Design of experiments, multiple regression, logistic regression are the tools that are used in this process. So in the improve phase, the question that is answered is what needs to be done. Then comes the control phase. In the control phase, outputs are optimized. To achieve long-term gains, control plans are implemented. And the processes that are used are optimize the outputs, implement the control plan for process input and output variables, transitioning project to process owner and team members. So the tools that are used are advanced DOE, transition plans, control methods. So in the control phase, we answer the question, how do we guarantee performance? Clarify process management plan and responsibilities, standardize process, establish process monitoring, evaluate results, and document key learning and identify transfer opportunities. Then is the last phase, which is the realize phase. The project is handed back to the process owner. The project results are tracked for a period of 12 months around. It depends on the organization for how many months they are going to track the project. And then in the process, we understand and embrace the team solution, track project gains for 12 months or whatever time the management decides, and assist with the selection of new projects. Then the tools that are used are control plans, transition action plan, final financial validation, and final report. In the realize phase, the question that is answered is how to stabilize. Indicate new process into day-to-day business, new process that realizes expected benefits, and then close off the projects and celebrate. So it's now celebration time. So we see that it is a funneling effect. The measure phase, analyze phase, improve phase, and the control phase. This is basically a funneling, has a funneling effect. In the measure phase, 15 to 70 excess are identified. In the analyze phase, it reduces to 7 to 15 excess. And in the improve phase, it reduces to 3 to 7 excess. And in the control phase, 3 or fewer excess. Only the critical excess need to be monitored and controlled for long term. Till now, we have discussed about the concepts of Lean, Six Sigma, and RDMAICR process improvement methodologies. Now we are going to discuss about the application of Lean Six Sigma in project engineering. Let's see the application of the Lean Six Sigma in projects. So we will start with the process improvement project ideas in EPC projects. The idea one that we are going to discuss is the reduction in schedule time for area substations. We all are aware that an indoor substation supplies power to various facilities in a plant. Substation is a building that is housing the transformer, switch gears, communication equipments, and that is required for the power supply. Now, during the construction of the project, these substations supply power required for construction work. So you can understand that it is a very critical activity. The substation needs to be ready within a stipulated time so that it can supply power to the construction work. Now you can see that the design inputs from package vendors comes in late and hence have an impact on the downstream engineering and construction activities. So to prepare an issue a substation civil drawing, the informations that are needed, the inputs that are needed are the design criteria, construction requirements, building locations, then the architectural layout, vendor information, electrical equipment layouts, and also we need the resources, obviously, the engineers, the technical reviewers, the peer reviewers, and also we have to get an approval from or the guidelines, specifications from the customer, project manager, construction managers, and client owner. So we can see that also the guidelines are needed, that is the engineering drawing procedure, technical review procedure, and client approval. With all the things together, all these are available, then only we can issue the substation civil, prepare and issue the substation civil drawing. So at this point of time, what we see that the primary metric is for this particular problem is delay in getting the deliverables from the customers, that is the civil drawings for construction, and the secondary metrics are man-hour and project cost. These two metrics we have come up with after analysis. Now we did the fishbone process mapping, then the fishbone and the 5 whys, then XY matrix. These all tools were applied on this particular problem statement, and then rather process improvement project ideas, and then we came up with certain probable excess. We found out that the vendor package GA electrical vendors, GA, these all of the are the inputs for this particular project. Location of substations, cutouts, architectural inputs, completion of vendors, structural design, and IF statements issued for construction of electrical layouts. So on analysis, what we found out that if we, the actions that came up are determine standard substation, module width and length. This design activity starts early. So whenever we are trying to start any activity earlier, there are risks involved of rework. So when we are thinking of rework, then we have to try to minimize that risk, control that risk. So the management has to take all requirements to minimize that risk in the project. The improvement actions are then taken, and so we can see that the before and after graph. The before graph, all the activities were in series, but in the current graph, we can see that the activities are being conducted parallelly. And hence, we see that earlier we were completing the same activities in a cycle time of 28 weeks. But right now, we are completing the same activities within a cycle time of 19 weeks, reducing 9 weeks time. So we can see that this is a very effective project improvement process idea. Then the next idea is reducing the number of revisions to the pipe specifications for projects. In oil and gas projects, if you are aware, piping material specification is a key project document. So there are a lot of piping activities. When the piping specification is revised, it can potentially affect a number of downstream activities, causing a significant amount of rework. So the process team requires input from 4 different disciplines. Input changes occur regularly through day-to-day modeling, hazard reviews, and model reviews. For this, we had to do the fishbone diagram, XY matrix, FMEA result, and then we got the results. X1 variation in pipe classes, X2 timing for component identification, X3 completion of acoustic analysis. These were the 3 causal factors which came out after doing the analysis part. Summary of key improvements is create a piping specification template for projects, create a procedure for developing project piping specs, update piping specification change request form to add reason for change, perform acoustic analysis prior to completion of 50% model review using PNIDs. Lean Six Sigma is very successful in manufacturing industry. In manufacturing industry, processes are highly automated and are repetitive in nature. Whereas in IT industry, success is more dependent on human interactions and communication. It is not pure science, and the processes are less repetitive in nature. But still, we find the application of Lean Six Sigma in IT industry. The Lean Six Sigma in IT industry is utilized for improvement in customer satisfaction scores, improving quality of the IT product services, reduce setup times for product features, improve utilization of servers and other hardware resources, reduce cost of services, and improve workplace organization. And there are several other aspects in which we can utilize Lean Six Sigma for value addition. Then the Lean Six Sigma in construction industry. Primary defects in construction industry are delay, rework, and cost overruns. Six Sigma can be used to reduce these defects. Six Sigma is very popular in manufacturing industry. So in that, you can see that reduced quality defects in manufacturing processes, reduce manufacturing cycle time, improve employee efficiency, reduce finished goods inventory levels, improve customer satisfaction scores, reduce non-value-added activities, improve inspection procedures, reduce time to meet customer requirements, improve workplace organization, reduce variation in manufacturing quality, and standardize workplace. Some of these projects are more suited for Six Sigma type projects and others are Lean type projects or processes, and some may require both Lean and Six Sigma toolkit. Till now, we have discussed about the concepts, the process improvement methodologies, the application of Six Sigma in project engineering. Now let us see how leadership plays a role in this as a success factor in achieving the targets. A lot of discussions are woven around how an organization's leadership plays a key role in Six Sigma. This is because the entire success of Six Sigma projects lies in the support and interest of top management. Top management has a huge responsibility in driving the Six Sigma culture in an organization through committed leadership. Lean Six Sigma organizations have the power to foster a climate of continuous organizational change by aligning the organization's vision to the excellence model. When top management decides to change the organization culture, all steps are taken to accomplish that. A good communication and a leadership based on employee motivation can make important steps in developing continuous improvement projects. Transformational leadership is when the leader's behavior influences followers and inspires them to perform beyond their perceived capabilities. Transformational leadership inspires people to achieve unexpected or remarkable results. It gives workers autonomy over specific jobs as well as authority to make decisions once they have been changed. This includes a positive change in the follower's attitude and the organization as a whole. Transformation leadership typically performs four distinct behaviors, also known as the 4 I's: idealized influence, individualized consideration, inspirational motivation, and intellectual stimulation. Transformational leadership enhances the motivation, moral, and job performance of the followers. This model highlights two factors: consciousness, that is awareness, and skill level, that is competence. Leaders need to target to align everyone in the organization into the skilled stage of unconscious competence by transformational leadership. Most exciting and powerful as of Six Sigma is that it touches everyone in an organization. It engages all levels to make it happen. And as been quoted by Jack Welch, Six Sigma is a quality program that, when all is said and done, improves your customer's experience, lowers your costs, and builds better leaders. We have discussed several aspects of Six Sigma. Now let's see the benefits that are there. And we should remember that every system, every methodology in practical world has advantages as well as challenges or disadvantages. So let's discuss about it. The benefits of implementing Six Sigma are improved productivity, reduced cost, boosts clients' confidence, gain credibility and stakeholder trust, reduced employee turnover and training cost. So in short, these are the benefits. Then the challenges that we face are need to lead by example, high change management requirement, high cost and dedication requirement, risk of early inexperience, scarcity of skills. So these are the challenges we face. Thank you for attending today's presentation. Your time, attention, and participation are appreciated. And while we are together virtually this year, please embrace the opportunity to take in as much as you can presentations, keynotes, and career fair. For now, enjoy We Local India virtually. We are resilient and you matter. I hope to see you all in person next year. Thank you. Any questions?